In Module 8, we're going to talk about error handling. Now, you're all experienced programmers. I'm sure you have an understanding of basic exception handling already. We just want to flesh that out and make sure you understand how secure coding is affected by error handling. So we're going to introduce the concepts as if you didn't already know, but I'm sure you do know some of this. We're going to discuss the need for error handling, and we're going to look at specific defensive coding practices against information disclosure, against improper error handling, and we're going to see how this is implemented in ASP.NET Core, as well as looking at auditing and logging best practices. The bottom line is exceptions occur. Errors happen. Someone tries to divide by zero, something of that nature. Exception handling is all about ensuring this doesn't totally crash your application, making sure we have some way to handle this and that there's not a default error page or a complete application crash. Improper error handling can crash the whole system in the middle of an important operation. It could also expose your data. It could affect confidentiality, integrity, and availability in a very negative way. Now, even if you have error handling, but it's not done right, that can give a path to the attacker to give them more information to attack your application. We're going to look into that during this module. Let's start with that improper error handling. I love this quote. Beware, an error message is worth 1,000 attacks. The bottom line is when you give an error message to a user, an overly detailed error message gives lots of information about internal structure of the application, perhaps back-end database information, all sorts of things. That's, first of all, very, very useful to an attacker. They now know more about your system than they did previously. In fact, skilled attackers will intentionally try to elicit errors, particularly in web applications, just so they can see the error messages. Now, the other side of this is overly detailed error messages are not very useful to end users and usually just confuse them anyway. So here, let's look at some of the issues. The .NET framework, if you just use exactly what it bubbles up to you, it's going to give you lots of important debug information. But that was meant for you, the programmer, to see and understand. It wasn't meant to show the user. And here we see a 404 error message where it tells you specifically what happened. We're talking about the application it occurred in, all kinds of things. This is a little too much detail. Now this one is even worse. We have an exception raised, and here you're seeing the specific line of code. You're seeing the stack trace. Now, if I'm a bad actor attacking your website and I see this level of detail, I've got to be honest with you, I'm very excited because you've just told me so much about your application. I'm even seeing some of your underlying source code. Wow, that's a whole lot of reconnaissance you just did for me. We do not want this to be displayed to the end user. So what should we provide? We need to consider the type of information. What does the user need to see? What should be shared with the user? And is there some way we're asking them to solve something? Are we asking them to do something different? For example, if the issue is network connectivity, we might ask them to ensure they're connected to a valid network access point. Failing to secure the state. When you have an error handle, you need to handle it, not just note it. Now that sounds odd. We talk about error handling, but a lot of people put a symbol, try catch block, log the error, but don't actually do anything. In some cases, that's okay. For example, if someone tries to divide by zero, you just tell them you can't do that. But in other cases, we may need to recover the application, secure the state of data, close resources, end critical tasks, any sort of things we might need to do when we're handling that error securely. Code level exception handling has a structured approach to handle exceptions. You have your try, catch, and finally blocks. You should always have that. Now there are page level handling done with the page error event handling. It's called when something was not handled by the try, catch block. Then there's application level exception handling. If something wasn't handled anywhere else, it's handled in the application error event handler. Now you should have all of these in place, But your goal is to handle everything at the code level. In your individual functions, try, catch, and finally blocks. The page and application levels are just backups in case something wasn't handled elsewhere. Let's talk about defensive coding. Here we see, as we've seen throughout the modules, vulnerable and secure code side by side. The vulnerable code is giving the entire stack trace and displaying that. The secure code is just giving a basic error message. The one on the right gives less information to an attacker, but enough information to a technical support person who can see what the error is and perhaps report it effectively. We're seeing the same thing here again, where we're seeing a stack trace at the page level versus just a message. Now this is illustrating that whether we're talking at the code level, page level, or application level, we never want to display the stack trace. Now you may have a scenario where you want to log that to a file on the web server for programmers to view, but you never want to display that to end users. Here we're seeing the same thing at the application level. Same thing, we don't want to give that stack trace away. Now, when we talk about displaying detailed error messages, custom error pages may print the stack trace, which gives too much detailed information. So here we're seeing an example where we default redirect them to the default error page, and they're using the division by zero. Instead of just saying attempt to divide by zero, this website is giving out source, lines of code, all kinds of information. That's too much data. So here we've done it much more securely. We have a default error page that simply says, sorry for your inconvenience, we'll be back with a solution, we appreciate your patience. That's a much better way to do this. We've notified the user that yes, there's an error, we're aware there's an error, but no, we haven't given away any information that an attacker can exploit. We see another example here of the stack trace being shown at the application level versus simply a message. This is a common issue, and here we're looking at transferring of control of the error page using server transfer. So here we're going to transfer specifically to an individual page, but we're only going to give a little bit of information if something goes wrong. We're seeing another example with the simple exception toString. Much like the stack trace, the toString gives a lot more information than it should. Not the same information as a stack trace, but more information than it should. The x.message is the preferred thing to use. It gives brief information. What about improper error handling altogether? We've talked about too much information. What about just not doing good error handling? Here we have an improper approach. We're simply going to throw the exception. Now, I'm not a big fan of that, but a lot of programmers are. But we're simply throwing a generic exception. On the right-hand side, we're throwing a specific file not found exception. If you're going to throw an exception, let's throw the most specific exception that's appropriate to the issue so that it has some meaning. Here we have an exception that's cached with the generic exception class. This catch statement is simply going to catch any exception at all. If instead of that, we also have before it a file not found exception, we can specifically handle that particular exception. Now these will happen in a nested hierarchy. What that means is as soon as the error handler has found some exception handler that will handle the exception, it stops processing. So we always put the more specific first, then the more general. So here, if it's a file not found exception, then that catch block will be invoked. But if not, if there's some other exception, we still have our general just catch anything. I always recommend that general catch anything exception at the end after our more specific exception handlers. Now here's an issue. You can see bad practice and good practice shown side by side. The bad practice on the left, we have a catch, but we don't do anything. We just return. Now that process will prevent the application from crashing, but we haven't handled the exception. On the other side, we're actually doing something more specific. We're telling the end user or the calling function what went wrong and how to fix it. What about cleaning up code? On the left-hand side, we first delete the file in question that gave us the problem, and then we throw, but we don't throw anything specific. On the other side, we're going to delete the file in question to clean up the code, and we're only going to do that in the finally block. You notice the difference. On the left, we're trying to do it in the catch block. In the right, we're doing it in the finally block. After we're done doing anything else, let's clean up. So cleanup code always goes in the finally block because we want to clean up whether an exception was generated or not. Vulnerability and rethrowing the exception. On the left-hand side, we clear out your stack trace before we throw it, which means whatever happened before doesn't show up. On the right-hand side, we're throwing it without clearing the stack trace so that someone who's catching or logging the exception further up the call stack will see the complete stack trace. That's why the one on the right is considered a good approach. Unhandled errors. Custom error pages can be used to manage any unhandled error in ASP.NET. So you have the custom errors element in your web config file. We can see that here where we have a custom errors tag that's being set, and we're setting it either to on to display the error message on local as well as remote client space, or off, we disable the error message on both local and client, or remote only show it to the remote. This is kind of important because error messages that are displayed locally mean on the server itself. Unobserved exception vulnerabilities. You have some function executing, and exceptions on that task are unobserved, which could lead to the process to crash. So let's take a look here. We have throw unobserved exceptions enabled equal false. In other words, if something isn't caught, just throw it. Now what will happen is eventually this bubbles up to your garbage collection routine and the entire process may crash. Here what we're saying is throw unobserved task exceptions to true, so we at least will throw them somewhere and hopefully another catch block will handle them. It's not your best bet. The best bet is to have try-catch blocks everywhere, but just in case you don't, throw that unobserved exception so that potentially some calling function might catch it. ASP.NET Secure Handling Practices. First of all, global exception handling is done using some middleware. ASP.NET Core has a simple status code for any exception found in an application, and you can see here it's not a very good one. Simply saying this page isn't working isn't terribly informative. Installing the Microsoft ASP.NET Core Diagnostics package will give you additional exception handling in the middleware, and you have to configure that in your startup.cs file. So you include that error handling middleware, and it should be the first thing in the MVC pipeline. You also have server exception handling so that the server does not generate these 500 internal server error messages. Here we're looking at using developer exception page during development. This is for debugging, beta testing. Now in this case, we're going to do the opposite of what we told you before. We're going to give a lot of information because this is during development. We're not sending this out to the public. This is so we can debug our application as we're going through the development life cycle. Custom error handlers are always a good idea. You can put as much detail or as little as you like, depending on the scenario. I often like to give very brief information to the end user, but to log extensive information into my log file. And here we're setting this all up in the startup.cs in the config method. HTTP status codes. The use status code pages configures the internal server error, file not found, web server authorization, all those to return their status code. Again, we're configuring this in startup.cs where so much of our work in secure coding occurs. And we said app use status code pages. And we have specific pages for specific status codes. Use status code pages with redirects. We're going to do a URL redirection should we encounter an error, and that's occurring again in our startup.cs. And then we also have the option of use status code page with re-execute to re-execute the requested pipeline with some alternate action. These are just a few different examples of how you can handle status code with HTTP errors. Startup exception handling. What happens if something goes wrong on startup? You have to configure the hosting server's response to handle these errors. You can use the capture startup errors, and in this case you might want the detailed errors key so that you get details as to what happened. Startup errors usually indicate something fundamentally wrong on the server side, and the user is not likely to see them. Some do's and don'ts, just remember this. Using the action listener method can catch the exception and show a proper message to the user. Throw the exception from all supporting methods. Make sure you throw it with a particular exception. Use catch blocks when an exception is anticipated. Now, some people like to use those sparingly. I like to use them throughout the code. Try to create custom exceptions to handle all your business rules. Don't use a single try block for everything. You might have multiple different try blocks depending on different things you're trying to catch. Never use unnecessary catch blocks with exceptions. In other words, we want to have catches for the generic exception. We want to have catches for specific ones we anticipate, but let's not just make a bunch of catches for things we're not even anticipating. Don't just suppress an exception. Don't skip an exception to be logged into the logging system. Always log those. Don't wait for the exception to occur and handle it elsewhere. Handle it as early as possible. And try to avoid encountering exceptions. That comes down to data validation, ensuring we're doing things right to start with, if possible. For example, checking to see that a database connection is active before retrieving data from the database. That will avoid the exception altogether. Here we give a basic checklist, and these are many of the things we've already talked about. We're looking for efficient, clean, and unobtrusive error handling. You can see some of the items we've already talked about here. Not creating new exceptions, naming things appropriately, throw the closest matching exception. If you utilize this checklist to go over all of your exception handling, you'll drastically improve the exception handling in your ASP.NET applications. What about auditing and logging? We're catching exceptions, but do we know everything that's happening? Logging is recording something. You might log errors, you might log activities, but auditing is when you review those logs for troubleshooting. Auditing only works if sufficient logging was done. A secure application should log any information related to security, failed login attempts, errors, all kinds of things. Events logged related to security should contain information, particularly the date timestamp, user ID, perhaps IP address, any things that might be useful. Logs are records of all the user activities, and again, if you don't log things adequately, then auditing isn't going to help. This provides information so you can look at what happened. It may have been a legitimate problem or an actual attack. What kind of attack was it? If the application doesn't perform proper input validation, the attacker may just flood the logs with meaningless information. So here's where this module ties in with earlier modules. And that can mislead security auditors and make it difficult to identify what really happened. Some common threats to logging specifically. Obviously, any denial of service could make the log grow too large, and then it's not logging subsequent events. And of course, log wiping is an issue. Both of these are encountered all too often, and the mitigating steps are things like hardening the log server and ensuring disk space throttling prevents overwriting the entire disk. Giving fixed disk quotas will do the same thing. Bypassing the log with flooding the log. This is a common attack. The solution is to have a timer that basically restarts the log after a certain time or certain size. Log tampering can include wiping the log, malicious characters, all sorts of things. Proper input validation is the key to preventing log tampering. What should be logged? Any validation failures of input and output? Authentication failures and perhaps successes? Certainly authorization and session management failures? Significant application errors or system events that are related to security? Startup and shutdown. Anytime the application is started up and shut down, that should be logged. Any high-risk functionality that you've identified? and any legal issues that need to be logged. What shouldn't be logged? Never put confidential information to a log. You might indicate that user ID X had a failed login attempt, but you wouldn't put the real password in there. That's a pretty obvious example. If you must put any sensitive information, it must be encrypted. Any database records or tables, entire records certainly shouldn't be logged. Source code chunks certainly shouldn't be logged. A reference might be logged in some cases, such as go to function X, line number 3, sure, but don't put a chunk of source code in the log. Where do you do event logging? It can either be stored in a file system as a separate log or in a database, and there's not a wrong answer here. It depends on your scenario. I often use file system-based logging just because it makes it easier for me to read the text file. But for the same reason, some people prefer to put it in a database so they can execute queries, integrate with SIEM systems, things of that nature. There's not a wrong answer here. Just make sure you've carefully thought out which approach is appropriate for your organization. Log throttling. It's provided in the ASP.NET Health Monitoring System. It restricts the number of times an event is logged. In other words, if I logged a failed login attempt 500 times, is it really necessary to log it 501? It prevents those flooding attacks and some buffer overflow attacks we talked about. A health monitoring system is a logging system provided by ASP.NET for logging purposes. Here we can see some code examples. We have a buffer set to true. Now on the right-hand side, we've gone into the web config file, and we've actually set maximum buffer size, the flush size, all sorts of things to prevent the log from being overwhelmed. Tracing. This keeps track of application flow in .NET, and it's used to monitor conditions that lead to errors or perhaps attacks. A trace listener is an object that basically wraps the trace output, stores it in a file, perhaps even the Windows log or the SQL Server or Oracle log, anything of that nature. It gives a pipe that gives you tracing information you can review. The trace and debug classes of the System Diagnostics namespace are what you'll need to implement tracing. And here we can see source code with an event log listener, and we're doing event log tracing. And we've set this up in the web config, and you see two different examples of this shown on the screen here. Security concerns. Trace messages contain message headers. If tracing is enabled, those headers may be visible in the logs. They may contain information like query strings and body information, and that information could be useful to an attacker. So we protect the log files with things like access control lists. We store the log files with an unusual file extension that's not easily accessible via web request. Certainly don't store the log as an XML file. We give the absolute path of the log file in order to prevent an external party from finding it with a web browser. So our best practices. Don't let the user know where the log's stored. They don't need to know, they don't want to know. Don't store user-supplied data in the logs. Always treat user-supplied input as untrusted if it's necessary to log that information. Manage the audit log events with the help of log rotation so they don't get too big. Use the ASP.NET Health monitoring that we already discussed. Only allow proper access to the logging system. That should be tightly controlled. Keep everything away from the user. The user should not even know about the logging framework or be able to interact with it. Any external logging applications must be kept up to date. If you're not going to use the ASP.NET Health monitoring, disable it, but I recommend that you use it. Ensure attacks don't occur in a continuous sequence. In other words, we're fixing the logs. We want to make sure that things aren't just logged 500 times we talked about. See events in an application don't get delayed. They get logged right away. Look at storage issues and make sure log tampering is revisited. Look at that issue to ensure it can't be tampered with. Ensure all malicious data is handled in the logs. Make sure there aren't any coding issues. Debug the logs immediately if there's a bug encountered, and never store sensitive information in the logs. Are security-related events logged regularly? Check. You could initiate one with a false login attempt. See if it gets logged. Make sure there's no sensitive information. Make sure the logs are stored in a secure location. Look at the compatibility of your logging format and make sure that it can work with whatever event correlation software you're using. Make sure that unsuccessful and possibly successful authentication is logged. Check whether all application errors are logged. Make sure the file size of your log is manageable. You don't want a log file that's 100 gigabytes. That's not usable. Make sure no exceptions go unhandled. And make sure application-specific messages are recorded. So basically what we're talking about is ensuring we have not only appropriate and adequate error handling, but that it's done in a secure manner. We make sure that we understand what errors and exceptions are and that we have an appropriate exception handling mechanism. We have class-level exception handling as well as function level, and we make sure we have good logging and auditing.